Hello, very good morning all.
गावंडे सर नमस्कार. गुड मॉर्निंग.
गुड मॉर्निंग सर.
छान आहे बरं का वर्कशॉप, काल मस्त आलं सगळं.
थँक्यू सर. थँक्यू. थँक्यू. आता दुपारच्या ह्याच्यात लाईव्ह सेशन मध्ये फीडबॅक द्या.
यस सर, देणार सर. छान आहे बरं का, मस्त सांगितलं काल सगळे.
येस. थँक्यू. थँक्यू. जोशी सर, आमचं एनबीए झालं बरं का. नावकर सर जॉईन झालायत का तुम्ही?
सर नाही झाले जॉईन.
ओके ओके ओके. पाटील मॅडम सर जॉईन होतील एक 10 वाजता.
हो सर चालेल. Hello. Good morning, sir.
Good morning. Good morning, all.
Yes, sir. Very good morning. So we will start the session in 2 minutes. Hello. Good morning, all. Shall we start, sir?
Yes, sure.
Okay. I welcome you all for hands-on session. I request sir to start the session. Over to you, sir.
Shall I share my screen now?
Yes, sir, you can share your screen.
Is it audible and visual?
Yes, sir. You audible.
Yeah. And the slide is, the screen has been shared?
Yes, sir. Yes, sir.
Okay. So very good morning, one and all. I will just mug up few things which were discussed in the yesterday session. So before continuation for hands-on one. So in the last session, we have discussed what is MCDM, how it is being correlated with optimization, and how the decision making process is most critical when the number of alternatives and number of criteria or multiple criteria and multiple alternatives would be there. Fuzzy data in, so we need to find out. So these MCDM, especially, it's when we call it as a critical when the alternatives and attributes or alternative or attributes and parameters are more in number, so that the decision making process become more complex and complex in nature. These are few terminologies which we have discussed yesterday also. We will discuss one by one while going for this assignment itself. So everyone, I think everyone is with that Excel sheet which I had shared with you. Is my Excel sheet is now visible for everyone?
Yes, sir. It is visible.
Okay. So everyone has these table on that Excel sheet which I had shared with you. This is the outcome. Yeah, I think this is the sheet which I have shared with you. So it is we are going to now calculate the performance assessment of STPs. So there are 6 STPs and their corresponding values for the various parameters. And definitely when we are talking about the assessment or performance assessment, we need to focus on only the outlet parameters, not influent parameters. The raw sheet is here. The entire database I would like to show. It's like this. So just forget about this thing. Yes. So all these values are the field data. So it's almost a 1 year data set. It's, you may find it. So 6 months means curtailing everything, and so including the pre-monsoon, post-monsoon, some fake data will be there, some vague data will be there, some manipulated data will be there. So I have removed everything, and validated data I'm using it for this development of or performance assessment. The same parameters are there. I have mentioned the units also, just to highlight how the variation in units will be there, and again would like to correlate it with the process of normalization, where all these numeric data we are going to fuzzify it. The next step will be the fuzzification, and this the third row, that is row number 4 in my sheet. I think it is now more visible. This fourth row is the CPCB. These are the CPCB discharge standards. So we are going to compare it with the CPCB discharge standard, so that we can find out, we can compare it, we can get the idea about the performance of individual STP based on the CPCB guidelines, not the individual or in case of any personal perspectives. So the CPCB guidelines, CPCB discharge standards will be the standard one, and accordingly we are going to compare what is the performance assessment. So if you observe the readings, so many of the values are within the permissible limits only, excluding SS. You may observe it. So if it is 100 for discharge standard, and the maximum values, so this is the fuzzified one, but this one in the monsoon season, non-monsoon season, all these are the exceeding than the permissible one. Same case with BOD, same case with COD. So you may observe these are the raw values and these are the treated one. These are for treated one, after treatment. Coming back to our sheet. So what I have done over here, this table includes, you may find the values in the ranges. For example, for STP1, temperature has been found minimum in the year, minimum 24 degrees Celsius, maximum 39.6, like that. For STP2, for STP3, for STP4, STP6, like that. So every time you will find the min max values of entire database. So whichever database you have, Just identify minimum and maximum value. And as 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 I discussed yesterday, the fuzzy logic do not work in the Boolean set theory, whereas it is a fuzzy set theory where we always work with. So I will come back to this set theory or membership function. So when you talk why we need to work in the ranges, so this is the membership function. Membership function is nothing but it is a simply our algebraic set theory. It is as like our algebraic set theory. But in case of algebraic set theory or Boolean set theory, the assumption is there will be the possibility of only yes or no. So whether that element is the component of this set A, if it is a yes or no, there is no any excuses in between that. So when you talk about the ranges, definitely this fuzzy logic will help you. So this membership function may be a triangular one, trapezoidal one, and the fineness of this is this. Let me on this my pointer. So this triangular MF and this fine structure of triangular MF is Gaussian one, and trapezoidal is the bell-shaped one. When we are going to use this triangular, for example, take an example of this. At certain extent, the value will increase, and after a certain treatment, it will go into decreasing. So it's membership function. Whereas in trapezoidal, for example, if you are getting the say income of any person up to certain age versus income, up to certain age it is a need, then it starts to increase, then remain stable, and then it starts to decline. So these kind of membership functions one can use depending upon the which parameter you are handling. And the Gaussian and bell-shaped or generalized bell-shaped membership function is the fine structure of this triangular and trapezoidal one. So in case of set theory, so ranges, in case of ranges, so this is a typical application why we need to work in ranges. So if you call about, say this is the range of say first membership function, so up to 20, and next is say, so for these particular values, say 18 will be having say this is the set of slow, this is the average, and this is the set of fast. I'm taking the example only. So these are the crisp values and versus the normalized value. So in case of normalization, the maximum will be only 1 or 100 or 1000. So it will be start with 0 and it will end to 1. So maximum will be 1 in case of normalization. So here, if I take an example of say 18, so 18 has the membership in slow set comparatively lesser and higher, whereas at 0.6, whereas in average set its membership is at 0.3. If I move in this direction, so it may be here, say take an example of 20. So 20 will be the maximum membership, means is say we can say its ability to remain as a member in the set of average will be maximum in average but least in the slow or null in the slow set. So this can be only possible when we are overlapping the set, and that is why we always work in ranges. And so the values mentioned for this individual parameters, so these are all the min max values for individual parameters, and accordingly we are going to find out or form the different sets. Now the another thing we need to find out, that is linguistic variables. The linguistic variables, this is another good example to know. Rather than to say the temperature, when someone asks you what is the temperature at your city, so we first reaction by a layman would be it's either in this linguistic form. Nobody said that today it was 23.2 degrees Celsius. We normally say that this is somehow warm, somehow hot, or it's very hot, like that. So fuzzy provides you this kind of flexibility to express yourself, or any layman can express the variables not in a numeric form but in linguistic form, which is more convenient to understood and to be processed as well. The thing is that for individual linguistic variable, you have to set the fuzzified numbers. So the linguistic variable is temperature, and for this linguistic variable, very cold, cold, warm, hot, very hot would be the linguistic values. Below these, we are going to form certain rule. It may be a typical rule-based approach where if X and Y then Z means if pH is so and so, alkalinity is so and hardness and so, the water is so. So like that. So it is a one kind of the rule-based system. Sometimes you may add as like a set theory, not an or and like functions that we call it as a fuzzy operators. Now coming back to our main problem. So this is the slide which yesterday only we have discussed. Is a typical flow chart of decision making. Define the decision goal, identify criteria, list alternatives, construct the decision matrix. Now we are in the step of, we have identified the criteria. That criteria means we have identified on which parameters. So in this particular case, my criterion would be this one. So STP1, STP2, along columns there is STP1, STP2, STP3, STP4, STP5, STP6, and these are my all criteria on which basis I am going to, I will just make it zoom. So all these are the STPs from Gujarat state only. So these are the 6 STPs value, minimum value and a maximum value for individual parameters, and these are the parameters on which basis we are going to assess its performance. Now in the next row, next table, so here we are forming the fuzzy sets with reference to linguistic variable. So for this, I have defined the sets by using the linguistic variable as highly significant, significant, average significant, low significant, and negative significant. The short form for these are NS, LS, AVS, like that. And accordingly, the fuzzy numbers, the sets will be as from 0.0 to 0.2. Definitely, as we are normalizing the things, the maximum value will be 1. What is the application of these? So you need to involve those experts to get what is the significance. I have mentioned the 2 examples. So someone may define the linguistic sets as like most important, important, average important, like that. It's entirely depend on the analyzers or assessors. There is no any rule that for these linguistic variables. These are the linguistic ones. These are the adjectives only. You can use anything. Powerful, most powerful, like that. Anything you can use, no problem. The thing is that it must be interpretable to everyone. And so this is another Google form. So just prepare one Google form to get the relevant or significance evaluation of different characteristics in municipal wastewater treatment by different experts. These experts would be from maybe academician, maybe industry person, maybe the chemist on the plant. He also knows well about what is the significant parameters in wastewater treatment. So maybe the end customer. So anybody can be the expert depending upon the assessor's judgment. And accordingly, you have to share. The earlier, you may use directly a hard copy. You may circulate the form, physical forms, and you get the opinion. So when you get the opinion, because nobody knows what is that highly significant means. The person or expert has to submit his opinion on the basis of only linguistic variable. For example, for this particular form, the expert will rate the importance of pH. Just I am reading this question. Rate the importance for pH in municipal wastewater treatment with ASP as a principal treatment mechanism. Because depending upon there are multiple approaches in wastewater treatment plant. So the person or perception may vary. And so I have mentioned over here that if ASP is the principal treatment mechanism, what is the importance of pH? So expert is not interested to scale in terms of on the basis of 0 to 10. It may not be more, we can say it is a more rigid. Rather, if he could submit his relevant significance in terms of such means linguistic variables, most important, important, average important, or highly significant, significant, average significant, low significant, or negative significant. So accordingly, after getting this response, one can analyze what is the mean. If it is for pH, if it is a majority of experts gives you the opinion at it's a significant one or highly significant one, means it indicates it is in the set of 0.7 to 1. So all those values comes in between 0.7 to 1. You will consider as it is a membership of HS or highly significant set 0.7 to 1. At the same time, those have submitted as S significant, but same thing here we have provided some laps 0.7 and 0.8 are same in both set. But as discussed here, the membership of that particular set to be here. So this is the case. So in the this may be the significant higher significant or significant. The membership of these particular 0.7 may be the highest in this previous set but lowest in the next adjacent set. So this could be possible in the degree of membership type function. So in the next step, I have done the average value and yes, I was here. So you may get the feedback from Google form like this one. So environmental expert 1, environmental expert 2, environmental expert 3, like 6 or 7, or mostly even number, odd number, that depends on the decision making. So at least 5 to 6 or at least up to 7 environmental experts need to be involved in this process. And accordingly, I am getting some responses like this. LS is nothing but low significant. HS is highly significant. And I am now going to convert these into fuzzy decision matrix. So these are my expert opinions and these are my parameters. And accordingly, I have converted. Just I have converted this LS I am going to replace with this 0.1, 0.2, 0.3, 0.4 in the same cell. Okay, so just I have converted these into. Now the individual one for first value only 0.1, 0.1, 0.3, 0.3. So individual parameter for temperature purpose, the average will be the average of these four 0.53, 0.43. So average of 0.1, 0.1, 0.3, 0.3, 0.3, 0.3, that will be 0.33. So accordingly, I have just made this average of individual one, and the average of these things I am considering as an average fuzzy number. This is one of the approach to get the weight for individual parameter. For example, for temperature out of 1, if I consider 1 as a maximum one, so for temperature its weightage is 0.09, whereas for TDS its weightage is 0.14 or 14%, one can say as a 14%, SS 13.66%, BOD as 14.8, but it is a normalized weight, so we cannot mention any unit at this particular step. It must be a unitless. Normalized means there is no any specific unit to this. So this is the one of the approach to get the weight. Weight is nothing but its relative importance with reference to the another. In the another weightage, you may get, this is a very relative importance weight. This is a generalized approach which is being used popularly to every parameter equal weightage system. This is the equal weightage system. TDS will be the highest one, BOD will be the highest one, COD is comparatively lesser one, chlorides again the highest one. So this is entirely based on, and the third one is based on the Satis hierarchy theory, where you have to rank the systems with Satis ranking mechanism or Satis theory based on its relative importance. With you need to find out the correlation analysis of entire data, and accordingly you can find out the direct relationship between individual parameters. That is another parameter, another approach of finding out the weights. So we were here. So this is my range, initial data for individual ranges. Now in the next table, I have made the average of these things. I will go to the Excel sheet. So in the next step, we have to calculate the average of these 24 and 39.6. So for individual parameter, if my temperature range for STP1 is minimum is 24, maximum is 39.6, the average will be 31.8. So you may try the formula, you may get it out from here. I will just make it more clear. I think it's more good with sufficient. Yes. Okay. So this is just an average of these ranges. So 13.60, that is average of this 24.1 to 37.1. For STP2, the minimum temperature range is 24.1, maximum is 37.1. I am calculating the only average over here. So one can start with this Excel sheet, that is, so all these are the average values which I mentioned over here. So I hope you are performing parallelly. Now the next step is to normalize the things. Why we are going to normalize the things? Because we need to remove these units, and for that purpose we are going to normalize. This particular column is for summation. I am just highlighting it. This column is the summation of all, horizontal summation. I think you will get more by this one. So sum of this all is being mentioned in this particular column. For individual column, we have mentioned 5. So this for summation, once you are take this normalization, yes. Why we need to normalize the things is the membership degree of x in A, mu of AXC. The height of A denoted by height A corresponds to the upper boundary of the domain, upper bound, maximum limit of the domain and codomain of its membership function. And so A is said to be normalized if and only if H is equal to 1. So here we always converting these into 1. So that is why, so this is my normalized value. So it will be always 1. How it could be 1? So just divide it by total sum of these individual ones. So normalization can be calculated by the individual value divided by the entire one. Means this normalization provides you the membership or contribution of this entire value of this first step. So normalization we can conduct by simply just 31.80, which was the average value, divided by this 180.90. I have not mentioned formula over here directly. One can put the formula, just you have to input so you have to divide individual average value of each STP with the summation of this one. So you will be here with the normalization. Hope we have reached up to this step. So it's simply getting the summation and dividing the summation by each value, so that the normalized value we can get it or put up in the table. In the next step, this here we are applying the weights. I am considering the final weights as uniform weight system. I am using this uniform weight system. So all the experts have mentioned that for temperature it will be 2, for TDS it will be 5. And accordingly, I have found just multiply whichever weights you obtain at this stage. For example, 0.174 into this individual value, 0.347. So one can get the formula. So J13 means this value divided by the individual this weight. Okay. And we are preparing this table. So this is my normalized value. This is my weight. One can use the weight as discussed earlier by another approach where we can calculate the weight like this. One can use this weight like this. The uniform for temperature, for all the values, you can multiply it by 0.09. For TDS, one can multiply it by 0.1429. For SS, 0.13, like that. So these are the weights, and just multiply it by our normalized value. Now, this color shade indicates. So once you are done, the normalized value versus or into the weight. Apply weights over here to your specified one. So these are my normalized value into corresponding weight. So you will be getting the table like this. Now, how these color bands, it is not necessary to just sort it out. You may get it a maximum and minimum value by simply applying the min-max formula to the Excel sheet. It is also more convenient. So just identify which is the maximum value for this particular row and minimum value for their particular parameter. So for this temperature, my minimum value is 0.34, maximum value is 0.3477, and negative ideal is 0.3237 for individual one. Same for TDS, same for SS, same for BD. So for individual row, take an example of say BOD, the maximum value 0.89. I am taking it as it's 0.91, sorry. Maximum value is 0.91, so I have mentioned as a positive ideal as a 0.91, and minimum value, that is 0.71, this one 0.719 as a negative ideal. So just make a table mentioning this positive ideal and negative ideal. So min max value, once you obtain the minimum and maximum value, now what is the meaning of this positive ideal and negative ideal? Now this is my ultimate solution, or we can say this is my ideal solution to its center, and all the values will be as like a cloud in between, maybe some away from the negative side and away from the positive side. I need to bring out all these values very close to ideal one. So this is my positive side, this is a negative side. So increasing preference and increasing preference, attribute x2, attribute x1. For individual attribute, I need to bring this towards the idealness. So positive ideal and negative ideal, I need to make this distance very close to each other, so that will be my best decision, that will be providing me the best score, in short. So that will be the positive ideal, negative ideal. So when you are getting the direct field values, normalize it, just apply the weight for it so that one can get the importance of individual parameters. And once you have found the positive ideal, negative ideal, positive ideal is nothing but the maximum value of that particular in that particular attribute. Negative ideal is nothing but the least value for all those. In this particular case, the positive ideal is nothing but for all 6 STPs, which is the highest number for the parameter temperature. For the negative ideal will be the least value for the parameter temperature amongst all 6 STPs. So that is why here we have compared. So my columns are all STPs, STP 1 to 6, and these are the parameters. So for individual STP, I am analyzing it, which is the lowest one, and or which is the minimum one, which is the maximum one. Now distance from calculating the ideal distance. So just take an example of our typical linear scale. The calculating ideal distance is nothing but finding out the distance. So this is my positive ideal. So if I am getting the distance of individual parameters, I am again repeating this table is same as like this one. So positive ideal means the value of individual reading from this positive ideal. So this is a clearly difference between 0.3477 positive ideal and respective reading. How to get it? So 0.3777, 0.3477 minus this in first reading. Fortunately, it's 34771 maximum one, and that is why we are getting our 0. Here. So what we have to do? Just in this table, the third step. So I am now at this table. I will highlight it. So this is the distance from positive ideal. Positive ideal means the distance from positive ideal. So 0.3477 minus 0.347, it will be 0. 0.347 minus 0.336, this way. So for individual point, we have to find out the distance, positive ideal distance and negative ideal distance. So you may find it sometimes, somewhere you may find it as a negative value, somewhere it may be the positive values. Here, this is again the second thing where we are getting the distance from negative one. Negative ones means E34 minus 0.32, so that means this is my negative ideal minus individual one. 0.32337 divide minus this one. So distance from negative, distance from positive ideal. Just make sure that it is from this point to negative. So here the formula changes as the value minus negative ideal. In this upper case, in the positive case, the field value or specified value minus our crisp value. That is the only change in this. The why we need to change this, I have already discussed this in last session. Okay, I will use this diagram only. Actually, this is as like this is my ideal condition. So I need to find out. So in case of positive ideal, so this is my positive ideal, this is my maximum value, this is the maximum negative. So this is negative value, this is the maximum positive value. I have to bring my every point to its middle, that is the ideal one. So to get the distance from negative ideal, so I have to make it from these to these. And whereas to bring these, I need to this point to its center. So distance will be the maximum value minus crisp value. In case of negative one, negative value, crisp value minus negative ideal one. So just apply the formula. You might be, it is also visible. So 0.3477 minus this one, it will be 0 for negative ideal, this value minus negative ideal one. Accordingly, you will get this table. Now, in the next step, we have squared. We have made square of individual. Why to square? To remove the negative values. So once you have squared it, make it square, then all the negative values can be converted into positive one because it is a distance, cannot be negative, and so we are now converting, we are squaring it, and I will get the addition at the bottom of this table. So I will again go back to the Excel sheet only. So here I have just get a square of square of this one, square of this one. So individual, and same for negative also. The same color code I am using so that it will be more convenient. Okay. So at this particular step, so we have found the distance from positive, distance from negative, and in the next step we have just made a square of individual value. Why to square it? Just to remove all these negative values. And this will be the sum. So the last row is the summation of all these. This last row is the summation of all this. So we directly put a formula for this to get it the addition. Now, here I am getting the summary of whatever we have done till now. So for HTTP1, so maximum positive will be 0.1485. So for HTTP1, so here now it has been turned. Sorry. Yeah. So up till now, my columns were HTTP 1 to 6 and particulars were, parameters were in the rows. Now I have changed it. These are my attributes, HTTP 1 to 6, and now out of these earlier one, so when we have found out these ones, so this is my HTTP 1, this is my HTTP 2, HTTP 3. So for individual parameter, I am getting the maximum one as this one. 0.1485, 0.53. I will again go back to the Excel. Yes, for individual one. So this will be the positive and negative. This will be positive and negative for individual one. For this is for HTTP 1, this is for HTTP 2, for HTTP 3, and their individual values for respective parameters. Now, this is the last step where we are going to apply the formula. So once you have prepared this one, so for STP1, this will be the maximum for that particular parameter. This will be the, minimum and maximum. For STP2, the corresponding values in the, yes, this one, 0.1485, same figure, 0.5385, negative, positive, negative. Okay, for individual one, for individual STPs. So just have a look on the formulae so that now in the last step, we are now very close to the conclusion of ranking or assessment. So here I am going to apply the formula that the once I have got the positive value and negative value, I'm sorry, just I will put your negative one. Okay. So this is my positive and this is my negative, means this value and corresponding value of individual STP. Now here I am finding out the score as dividing these negative value, means these you may get this negative divided by negative plus negative. I have mentioned this formula over here. Negative ideal divided by positive ideal plus negative ideal divided by 100. 100 is just to get it on the one scale, 0 to 100 scale. You may get it by 10, no problem. This is the distance. Again, this is the distance. We are calculating it from negative ideal, null hypothesis, as like a null hypothesis. We are going to calculate it from the negative ideal, and so negative ideal with reference to negative ideal, I am getting what is the value. So it will be the 78.37. Accordingly, the least will be, as it is the negative ideal, it is the distance from negative ideal, the least will be having a good score. In the other way, you may calculate in more detailed manner. That is just in the next step only I have done it. So this is, I have made it for 1 minus this one, 1 minus this one, so that I can get the actual distance, actual ranking of individual one. So in this particular case, you may observe for negative case, which was earlier in the rank 6, now this comes to be rank 1 when you are getting it as a positive one. So this is actually true result. So least one is the, or in the negative cases, the least one score with least one will be the ranking 1. So 82.17, that will be ranking with rank 5th. The 34.05 will be the ranking as 1. So this is the assessment or performance assessment for individual STP with reference to those 6 or 7 parameters. Just I will go back to the Excel sheet. I will just recap everything again. So we have started from this step. So this was the raw data with you. It was in the range. I already explained why it is more beneficial to get the range, and it will be entirely the user choice how to make the sets. How many sets you can make, that will be the only user choice. So that is why min max value makes a more difference in the entire assessment. If you want more and more or more specified manner or more complex model, which will be providing you the individual or more sensitive model, in such circumstances your sets will be more. Sets means less significant, higher significant, that you can add the more. I had taken the 6, but one can go for 8 or 10 sets. More minute level classification will provide you the good kind of assessment. So in the case of while deciding the ranges, you may form the sets in the different volumes. In the next step, next table, that belongs to the simply getting the average values of. Better to work on this. Yeah. In the next step, we have calculated the average values of this one, 24 and 39.6 average of this one. In case of normalization, just I have taken the average of individual row divided 31.80 by that sum. I am getting the normalization value. The major significance of normalization is to make everything uniform. Now I will apply the weights. Weights applied means whatever weights you have identified by experts, those weights you are going to apply in this next step to the. So this is my normalized value multiplied by weights. You will be getting this table. Find out the min and max value. The max value is being considered as a positive ideal. Minimum value is being considered as a negative ideal value. Now, in the next step, we are going to find out the distance of individual parameter from positive ideal and negative ideal. And so, we have made the difference between the positive ideal minus Cripps value to get the distance from positive ideal, and to get the distance from negative ideal, negative Cripps value minus this one, negative ideal value. So accordingly, this table has been prepared. Finally, square to add, to remove all the negative values, just so that it will be all positive one. And finally, rank the system, make the summarized table by converting into getting the summation of all those squared value at this one for the individual parameters. Now the parameters have been spoiled. There will be the single value for individual parameter and for all the attributes. Just apply the formula to get the distance from negative ideal, which will be the rank. So my rank will be 100 only when it will be very close to. So ranking is nothing but its closeness to the ultimate one, closeness to the ideal one. That is my ranking. And so I am getting it the distance from negative ideal. So reverse of this, the plant with least score, that will be having a good rank. In the last session, I have discussed some more models of MCDM, that is WSM, WPM, AHP, TOPSIS, and MCDM. Now WSM and WPM, these are nowadays somehow outdated one, but AHP, TOPSIS, and MCDM are analytical hierarchy process, TOPSIS, and MCDM. These are nowadays being popularly used. This is a comparison of all those MCDM approaches. So in the single table, so one can get a snapshot of this slide, a summary of all the approaches and entire thing means if you take the one row, so what happens in AHP, the form a hierarchy tree in accordance with criterions and alternative. Normalization will be taken place, then weights to the criteria are given as per SATI's 9-point scale, which I have mentioned. Pairwise comparison means how to get it, the individual or importance, relative importance, and these are the mathematical formulae to get the AHP as a score. In case of TOPSIS, form a matrix indicating weights, criterions are clustered, you can apply the weights just as we did it. So the same formula I have mentioned over here. So the calculate the similarity to the worst condition means negative conditions. So with reference to worst condition, we are comparing it. So that is why in case of TOPSIS, the same formula. In the last step, we have applied this same one. And in MCDM, the major advantage is for the linguistic variables. Averaging and aggregating falsified data to remove any negative values, again normalize it and defalsify it. And finally, one can rank the alternatives. Ranking the alternatives is nothing but you are finalizing your decision. When you are when you are declaring that this is the STP with a score 1, means that is the indication that you have now made the decision that this is the best STP. So this can be correlated with our decision making process and how mathematically or how using these such kind of soft computing tools one can go for the decision making. I would like to share one more sheet. This is another approach of MCDM, that is AHP. So those are from other than environmental domain. So specifically, I have done case study, one project was there. This is a decision for ranking the buildings or whatever the construction projects going on, whatever the projects going on. So one can rank the building, one can rank the construction projects or societies. So in the initial level, what I have made, so planning and design, structural aspects. So these are the parameters on which basis I am going to rank safety, hygiene. These are the subdomain or domain. Now in the second one, or just I will use these tables. So this AJ column is planning, design, structural aspects, safety, hygiene, amenities, green aspects. These are the main domain, under which I have these are subcategorized as in the planning and design: space utility, interior architecture, exterior spaciousness, ventilation, sunlight, etc. Similarly, for the next domain also, subdomain, domains and subdomains. I have made the complexity of the problem converted into some hierarchical one. Provided some weightage. So at this level, again, if you make the summation of these 5, 20, 20, so individual 20, 10, 10. So 6 domain, 100 weightage. But in the individual domain, I am now just focusing on this. I will just make it so. I think now it's more clear. For individual domain, this is the domain, this is the subdomain. I have get the values from expert. So according to you, the space utility will be having the maximum score as 20. Ventilation is also important, same weightage. Sunlight, same weightage. As compared to this exterior architecture as the least one, 10. How did I get these values? From experts from different domains. Maybe interior architectures, maybe the climate expert, maybe builder, maybe developer, maybe the occupants. All these are the experts to get these surveys. So from these experts, I get these weightages for individual parameters, and then now as a model, I just selected the 10 buildings from different areas: urban, semi-urban, and rural. So few of them out of these 10 buildings, few of them are from maybe from rural, maybe from some semi-urban, and maybe from urban. Accordingly, the people living over there submitted this score. Okay, and after this, I analyze it. So this is the analysis also. So this is a score which we have obtained from the field data. Same thing, just make it the sum of individual one. This is the sum of all these. Normalize these. Same procedure what you have learned just now. Normalize it. Just here I have applied the weight C16 to C17 means to these I applied the weight of individual one, and finding out the score by simply apply the formula. So accordingly, one can get the ranking to the individual project. So this is one kind of how one can display this rank to individual project. This may be the periodic process also. Occupants maybe submit their feedback monthly or bi-monthly basis. Accordingly, that score may change. The builder or developer or society members may get again the idea about how it is being operated, which is those factors are getting affected, which are those factors are running well. Everything you can monitor by simple getting the feedbacks. And nowadays it's very easy to get some apps which are very user friendly. This is one of the application being used of this one. So I have just added one more domain along with environmental domain, we can go for such different domains also. One more thing. I think last 10 minutes are with me. We'll conclude just a bit.
Doctor, you need to demonstrate any other, you can take your own time, no problem.
No, just I will conclude in 5 or 10 minutes only. Then we will discuss. I think it will be more better to have
Yeah,
any
yeah.
queries regarding this entire work. So that I will spare 10 or 20 minutes for this time. Just I am searching
Participants
for-
try to get involvement in your demonstration, please. If you have any doubt, please ask and share with a resource person.
Okay, so if you have done the same thing on the Excel sheet, then I think you may find some difficulties. It's a bit natural, but we can sort it out. So if you have any doubts, we can sort it one by one at any step. So just I will put the things over here. Our process starts with first of all, we need to prepare one Google form to get expert opinions with reference to its importance. So that is the very first thing we need to conduct. Once you have got the data, you can use it, such database, you can use it. The expert selection also, I will share some reference material for this also with the organizers. How to select the experts, how to make the comparison sheet, how to identify the expert, number of experts. So for everything there is a proper guideline, and one can go for it with a very systematic manner. So I will share all those reference material with the organizers so that they could share with you. I'm also sharing this presentation as well as all those Excel sheets with you also. So that it will be more convenient for you. In case of any doubt, we can discuss.
Participant, do you have any doubt, any query? Floor is open for the discussion right now. Doctor, I have one question.
Yes, sir.
Let's suppose any faculty wants to do the application of these physiologic or optimization techniques in their academic execution.
Surely, sir.
Because most of the things you know very well, all the NAC and NBA is the game of figures or numbers, right?
Yes.
So can we take away from the new approach that to be a part of new methodology or content beyond the syllabus by using this optimization or fuzzy logic? Could you please throw some light on this?
Sure, sir. Actually, for school education system, there is a one school assessment process. Now they have in the NEP 2020 they have launched this SQAF system,
Right.
something quality assessment framework SQAF.
NDRF.
Yes. So that belongs to the same technique. That is based on the same technique. But the thing is, they are just mentioning the quantitative approach only, not qualitative one. Means if there's something, for example, in our NAC or MB assessment, what we are mentioning, number of research paper, 10, 20, 30, 40. Do not bother about the H index. Nobody bothers about the what is the number author in sequence, whether it is a first author or second author or third author. So these minute level justification, these minute level assessment criteria can be involved in this particular case. So this will be not only the quantitative one but also qualitative one. So that kind of, but it will be more rigid. The model develop or the framework we will be going to develop, that will be extremely more complicated. We have worked one assignment based on for the city planning or town ranking in the smart city mission. So for that, there were in the first level, primary level, there were 43 criteria. Individual criteria was again subcategorized into almost 6 to 7. So the entire structure was with the domain, subdomain, subdomain with almost 600 to 800 parameters.
Great.
Now the thing is that it's a robust model. It's become a very robust model. The problem we face while getting the response from occupants. For example, normal civilian will never answer for 600 questions at a time.
Right.
We will have to make them clusterize. So that is the thing, how we can do it. For the NAC, we can work for the individual criteria only. So each criteria will be having one kind of one assignment and the respondents have to respond only for those specific questions. We need to clusterize the things. Then only this can be adaptable.
Doctor, how this fuzzy logic or optimization can help in developing models in a civil engineering domain? Is it a really tough one or a moderate one?
If you have sufficient database to build a model, at least 1 year database, for example, rainfall data,
Right.
then that we can get it. Groundwater contamination. We can predict it. Groundwater contamination for different sources. If you have the 6 or 7 bore wells or open wells, and we have to find out which is the worst in nature. So we can collect the samples for at least 1 year, analyze the things, we can get it. Same case with water sources, water bodies.
Right.
Same case with road conditions. Already we have done the assignments for solid waste treatment plants, urban planning, for road mapping, for that smart city mission. So Solapur city we have done it. Very recently we have done we working on the Badlapur city for route optimization as well as for the transportation location. So I am applying it very frequently, but the model may be different. So
Definitely.
parameters will be different, attributes will be different. It's somewhat challenging, but once you have developed the model, you can replicate it, you can use it for anywhere.
Can we commercialize the developed model by using these optimization techniques?
So one glitch is there that if you can go for the what can I say, the platform like our Android app,
Okay.
then it will be more, I think, usable.
Beneficial.
Yeah, then, yeah.
Doctor, I have one last question. As the database set or databases for the public sector or facilities freely available in Western countries. Did you find any same platform that could be available for the Indian scenarios?
No, it's true. It's difficult to get the database.
Because it seems we have everything except the data.
Data. True.
And all the Western countries are very much rich in the data sets.
Data.
They have data of everything
Yes.
with them.
You are absolutely right, sir.
That's why they are very much sure about the future and current consequences that to be come for the public sector.
Yes.
Okay. So this is all from my side. Participant, do you have any doubt, any question? That's nice. So once again, thank you, Dr. Guru Prasad Anavkar sir, for delivering such a great experience for all of us, for the hands-on experience by Fuzzy Logic and modeling that is useful for the environmental and civil engineering domain. But definitely by certain exercise and modification in the existing protocol or prototype of the Fuji logic, we can apply it for the different modules too. Thank you so much, sir. Thank you.
Thank you, sir. Thanks for the opportunity. Thanks to all
Thank you, sir.
participants also.
Please, sir. Thank you so much.
Shall I quit the meeting?
Please, sir. Please, sir. Thank you. Thank you. Participants, now feedback link is in available in a chat box. We request you to fill the feedback form, which will be not available on the WhatsApp group. I request all the participants, please stay here. Shortly we will start the next session by 11:35, or you can rejoin the session on the given time. And second, one important announcement. We have a validity function on 2 p.m. instead of 3:30 p.m. because we have one additional slot for the practice session, and due to some technical reason we have to postpone it. So I request all the participants to join the validity function at 2 p.m. as well as a next session at 11:35. Madam, please close the meeting and reopen it at 11:35.
Okay, sir.
Yadav sir, close. Participants, please stay tuned. The resource person can join shortly. Yeah, he is joined. Supriya madam, Panaskar sir is joined just right.
Okay, sir.
Hello, am I audible?
Yes sir, you are audible, visible both, but voice is little low.
Okay, am I clear now?
Voice is not clear. Voice is not clear. करा तुम्ही आवाज येत नव्हता एकदम लो येत होता.
Hello,
Yes, sir.
just a moment. Let the sir to be ready for the session.
Okay.
Nitin sir, once you are ready, just give us a thumbs up.
Yes, sir. We will.
Hello, am I audible now? Hello,
Yes, sir. You are audible.
am I clearly audible?
No.
Is it possible to
I'm not getting.
sir,
Can anyone please paste in the chat if I'm clearly audible?
through which system you are going to deliver, sir? I think microphone or something is.
Yes, I request someone to please message in the chat if I'm clearly audible.
No, sir, your voice is little low. Am I audible to you? Professor, am I audible to you?
Wait, sir. I will call.
Participant, please stay here. Shortly, the resource person will join. Don't leave the meeting.
Hello, am I audible now?
Yes, sir, you are audible.
Okay, okay, I have connected to the phone.
Okay, okay. No problem, sir.
Okay, okay, thank you.
I welcome you all for day 2, session 2, hands-on session on application of soft computing in engineering optimization by Dr. Nitin Panaskar sir. Dr. Nitin Panaskar sir is currently working as assistant professor in Department of Mechanical Engineering at Rajiv Gandhi Institute of Technology. Sir has completed his MTech in Mechanical Engineering in 2013 from IIT Hyderabad. Sir has also completed his PhD in Mechanical Engineering in 2021. Sir has vast experience in teaching, carrying various roles and responsibility with industrial experience also. Sir have received research grant from University of Mumbai for project IoT enabled smart window for controlling brightness, a perspective of heat transfer rate. Sir have also published various papers in reputed international journals. Sir have also attended many workshops at national and international level and training programs. Sir have guided the research project title investigation of sustainability of tool profile for enhanced tensile strength of weld in friction stir welding of thermoplasticity at district level of Avishkar Research Convention and was selected for state level convention. Sir have also received Homi Baba Young Scientist Award. So I request sir to start the session. Over to you, sir.
Okay, thank you all. I will just start the screen share.
Sir, your voice is not clear.
Okay, am I audible now?
Yes, sir.
Okay, I am okay. Okay, is everyone able to see the screen clearly?
Yes, sir, it is clearly visible.
Okay. When we start with central composite design, okay, we will understand what is optimization, what are the various tools we use, softwares we will use, and what is the purpose of these optimization tools. Okay, so this is the index. We'll just see the basics. What are the objectives, variables, design creation, evaluation of the design, then experimentation, then analysis of interpretation, diagnostic model graphs, and the points which we need to capture. Okay, so we'll start with the experimental design process. So this is the basic process which we understand. First, we define the problem. Okay, based on our literature survey and consecutive research gaps, we will define our problem. So that is your problem statement. Next, once you have defined your problem, we have to see how we can study that problem. Okay, so for that, we will require to convert our problem into a set of objectives. Okay, and these objectives then we will check whether they are being fulfilled. Okay, or we can create a solution for the problem by studying those objectives, working on those objectives. Okay, finally we'll brainstorm. Okay, so brainstorming is for the selecting the appropriate design. Okay, so in the real world implementations, there can be huge number of experimentations that may be required to say with a good level of confidence about the output what we can achieve or the output what we can predict in any experiment. So we can use design of experiments where we can go for either full factorial or partial factorial if you want to reduce the number of experiments. Okay, so mostly we'll go for the partial factorial because it will be very time consuming. Several experiments may take several hours or even a day for the experimentation. Again, we have to test it finally. That also takes additional time. So technically, we should try to limit the number of experiments without losing the statistical quality of your results. After that, we will go for this conduction of the experiments and collecting of the data. Then we will analyze the data, interpret the results, and then finally verify predicted results. So first we'll understand what are the components of experimental design. Okay, so there are three main components. First is the factors. Okay, factors means what are your independent factors. Okay, so if you are doing any experimentation, like say in mechanical engineering, if you are doing an experimentation, then you will have to specify factors. Like in manufacturing, you will specify the tool rotational speed, you will specify the tool feed rate, Okay, and you may specify any depth of cut. Okay, so these will be your independent variables which you can change. Okay, so based on your values of the recommended value of the manufacturers for the tool, we can have a good range of factors which we can vary independent of each other. Okay, so if I'm having feed rate, it may not directly be depend on the depth of cut. Okay, so we can vary them independently for the process. Next is the level. Okay, so how many levels you are doing? Let's say I'm selecting a rotational speed. So I will have a range of rotational speed like say from 1000 RPM to 1400 RPM. Okay, so that will be my entire range. Okay, within that range I can have 1000, 1100, 1200, 1300, 1400. Okay, so these will be my levels. Okay, so I can have around 3 levels or 5 levels. Okay, and I can specify the minimum and maximum value which forms your range. Okay, last is very important because this is what we are studying in the objectives, what output we are going to get. Okay, so normally when we are doing this mechanical engineering study, manufacturing study, we'll have the output in the form of like tensile strength, or it may be in the form of hardness value, or it may be in the form of smoothness attitude, or it can be thermal conductivity also, or electrical resistivity also. So the output may vary based on what is your aim or objectives of your experiment. Okay, so we'll come directly to response surface methodology, which we also call as RSM. Okay, so I'm just taking some time to give you a gist of what are the RSM methodology and what is this contents. Okay, because once we go to the software, okay, so we'll be using this design expert software for the study. Okay, so central composite design. So what it is an experimental design that augments your factorial design with additional points. Okay, now why these additional points are required? That is to allow estimation of curvature. Okay, so normally this type of model we'll use for the quadratic equation or cubic equation or cubic alias quadratic equations, which where the curvatures has to be studied. Okay, so mostly it is more popular for the quadratic effect study. So we can efficiently build second order model without running a full 3-level factorial experiment. Because so your full 3-level factorial experiments will have lot of experimentations. Okay, so it will be very much time consuming. So if you want to build a second order model without going for 3-level factors, then we can use this central composite design. Okay, finally the context, normally we are using this for the optimization of the process. Okay, so next factorial design. So we'll consider combination of high and low values of all the factors. So we may have 3 factors, as I said. It can be rotational speed, then feed rate, and depth of cut. So these will be my factors, and for each factor, I will have at least 2 levels. Okay, one level will be lowest level, another will be the highest level. So full factor will consider all the combinations, which will be huge list of experiment. Next is a fractional factorial. We will reduce the set of full factorial design. So that can be done by the CCD, or there are other models also which can reduce your factorial design. Okay. So before going forward, we just understand what factorial portion is. Okay, so we have these factors. Okay, where variables are set as +1 and -1. So these are your highest level and lowest level. The purpose of this is to provide information about linear as well as the interaction effect. What is interaction effect? Now linear effect is like, say if I am having linear value of rotational speed, which I can designate as say A. So the value A, which is denoting rotational speed, this is a linear interaction. But if I am having AB, which is affecting my final output, okay, so that is interaction of your tool RPM as well as your feed rate. Okay, so together they are creating an effect on the output. Okay, if only tool rotational is creating an effect or only if tool RPM is created, or sorry, bit rate is creating the effect, that is a linear effect. Okay, we can have interaction effect like AB, BC, AC. If your model is cubic, then you will have ABC effect also, and then you may have quadratic effect also, which will include your A square, B square, C square. Okay, those type of impact. Okay, so A square affect your final output, that is your ultimate tensile strength. Okay, then we are having these center points. Okay, so this is your center point. So this is for your estimating experimental error and checking your curvature. Again, we are having axial points where you will define your value alpha, that is used to capture quadratic, that is curvature effects. Okay. So both of them are important. We will require central points also, and then the vertex points also, and the axial points also, which are denoted as a star. Okay, so both of them are used for estimating curvature effect. Again, we will use multiple center points in our problem, because that will help us to check what is the repeatability. Okay, are we getting close values for the center points? Okay, so that is very important, because if your center values differ, then your curvature may be present. Okay. Okay, so next we'll go for the actual star point. What is alpha? So that is your factor. Okay, and alpha is required for ensuring prediction variance. Okay, so that is, we have to keep constant. So these values, okay, this has to be kept constant. That is the prediction variance. Okay, so that way we can arrange my star point. Okay, or axial points, I can say. Again, in design we can have different types of alphas. Okay, based on where it is located, whether it is outside the space, or it is circumscribed, or it is on the face, or it is interrupt. So that is the value of alpha. Normally we don't change the alpha unless there is a specific requirement of our experiment. Okay, so normally we'll keep the alpha default values what is selected. Okay, what are the benefits? As said, it is more efficient. We can do the study in very few number of runs. Okay, almost we can go to 50-60% of the experimentations only. Then flexibility, that is also there. We can augment it later with axial points, center points, and finally we can do the optimization to find the conditions that yield the best response. Okay, so what response we'll get from the manufacturing values is the optimum response for that particular value. But if I want to find the real optimized value, where I can vary my parameters within the higher and lower range, then I can get an optimum value which is predicted by the model. Okay, so first we'll do the experimentation. We will feed those values to my control composite design software. It will do two things. First, it will analyze the model. Okay, it will analyze the model, because if your model is not correct, whatever experiment we will be doing will be wrong. Okay, because if your model is quadratic model and you are using linear, okay, if you are doing the experiments in a linear fashion, then your experimentation can go wrong. Okay, so alternatively, if your model is cubic and you are doing a quadratic set of experiments, then also you will not get the accurate values. Okay, so you have to see what is your model, how your model fits with your data what you are having, and once your model is confirmed, like if it is a quadratic model, then we can go ahead and do the experimentations based on the quadratic model. Okay, but if your model is cubic, we should not do the experiments related to your quadratic model. Okay, so this also we'll see. So this is a sample case study. Okay, so we'll check the case study later on. So what are the objectives? Okay, so the objective what we are going to do here is your factor interaction. Like what is the interaction between two factors, like factor A, factor B, factor C. So we'll have two level interactions, AB, AC and BC, because we are in a quadratic model. If you are in a cubic model, then we can have a ABC also, A cube also, B cube also. Okay. Again, we can have alias models. Alias means there are some components which are quadratic, some components which are cubic. But of course, unless specified by the model, we will not use the alias model. So normally, alias model will have all quadratic terms and one ABC interactive term. That may be possible. Okay, so we'll take an example. So we are having this variable. So first we'll define the variable, then we'll define the dependent variable. First independent variable, which are your parameters, then the dependent variable, which is your the response, or we can call it as the output. Okay, finally we go for the design creation. Okay, so tell you how to do this. Okay, so first we'll have to start the design expert software. Okay, so how to start? Okay, if, you have heard about it. Okay, so what you can do, you can download it directly. Okay, so I have just embedded this design expert. Okay. So that is the software that we are having. So just click this. Okay, so you are,
Sir, voice.
yeah, sorry. Okay, so if you are on your laptop, you can just see this. Okay, so you are having this design expert software. Okay, the first you will see the first link is that is you can click the link. Okay, and from here we can have a free trial. Okay, so you can click free trial. Okay, so already I have already downloaded here. Okay, I have already entered my details, so you can download from here. So based on your system, you can download this 64-bit Windows. Okay, so this we will download, and after downloading, you can open it. Okay, so before opening, it will send you a link. Okay, what will say? Okay, so it will just send you a link. I will just open and show you what type of link you will be getting. Okay, so this is your email what you will get. So after downloading, it will ask you to log in. Okay, you cannot log in without registering. So you can take some time to register. So it will ask you your details which will be related to your name, your institute, other details related to your area, qualifications, and of course where earlier they used to allow Gmail or other emails, Rediff mail, but nowadays they are only allowing your official email ID. Okay, so if you are having the official email ID, okay, then that only you use for your registration. Okay, and after registration, you will try to log in. It will ask you for the serial number. So now I am having the serial number that we received. Okay, so I have already done yesterday, so I have received this, and you can enter this serial number. So you can use the first option, and you can enter this serial number. Okay, so once you enter this serial number, allow you this 14-day trial. Okay, so 2 weeks trial they are allowing. Again, earlier they used to allow a 30-day trial, but anyway, they are allowing 2 weeks trial which you can use. Okay, again this can be done by your official email ID. Okay, so I am expecting that you may have downloaded. So if you have downloaded, you can please uh, install it, and after installation you can do the registration, or maybe before installation it may ask you the registration, so that you can register with your official email ID, and then you can um, use it. Okay. Okay, so I will just wait for 1 or 2 minutes if anyone is downloading. Okay, so if you have downloaded, you can please let me know so that we can continue further. Okay, it doesn't take much time. Hardly it will take 1 minute for the downloading and the registration. And you can enter the link, okay, or the registration link that they have, serial number that they have sent you, and you will be able to um, use the software. Okay, if anyone having any trouble, you can please let me know. I think there is a straight procedure as I have already suggested. So you will have to enter the registration number, one-time registration number or serial number what you call, so that you can access it. Without that number, we will not be able to open it. Okay. Okay, so I hope everyone has already downloaded it. Okay, so I will start with Okay, so this is the image that we see. Okay, so I have already opened this software. Okay, so what we are able to see, we'll understand. Okay, so we are having this central composite design. Okay, you can even zoom it. Okay, zoom this if you are not seeing the font clearly. So first thing what I will do is go for this central composite design. Okay, so I will go here. Okay, so there are various options: standard designs, then factorial designs, regular two-level designs, randomized designs. Okay, I will go for this RSM, and in this we are having various options. I will select, yeah, central composite design. Okay. Now in our experiment we are having three levels. Okay, so what are the three levels I will just discuss? Okay, so I will do a quick insight. Description of what is our problem statement, and based on problem statement, okay, we will be able to understand what experiment we are doing, because after that only you will understand about the problem. Okay, I'll just open this new tab. Okay, so this is the problem what we are discussing. Okay, so we are having optimization of friction stir process welding process. So that is a solid state welding process in which we are having using two materials, that is aluminum alloy and ETP copper. And our problem is to weld these two materials. But again, these two materials cannot weld easily to each other, because aluminum is at 600 degrees Celsius melting point, and the copper is around 1100 degrees Celsius. And of course, when there is a heat in between these two materials, they tend to form this AuCl compounds, okay, aluminum copper compounds, which are weak and brittle, okay, which makes our weld very weak after the weld formation. So what we did here, we took a compatible material which is a zinc foil, and we placed it between the aluminum and copper layers. Okay, so now the zinc, copper and aluminum zinc components are formed, but they are not brittle in nature. Okay, so that way we can have a very strong weld if we are using a zinc foil between these two materials. Again, the welding is solid state welding, that means we are not actually melting them. Okay, so we are having this type of arrangement. The aluminum sheet is kept on top, below it will have a zinc foil, and below it will have a copper sheet, and we'll have the rotational speed, okay, of a tool. So this tool will be partially penetrated, okay, within the material. So it will be a small tool pin which will be protruded, and the remaining large diameter, which we call as the shoulder, that will be rubbing on your surface. Okay, so by frictional heat we are creating a plastic surface within the material which is just beneath this rotating shoulder, and that way we are able to bond the two materials. Okay, so the materials reach up to around 80% of the melting point of aluminum, and they are quickly bonded. Now what are our experiments that we need to understand? Okay, so there are three main parameters which we have to select. Okay, the first is rotational speed. Okay, so we have used the minimum rotational speed as 1000, maximum as 1400. Then the second parameter, independent parameter, is the traverse speed, that is the speed rate. Okay, speed rate means what is your tool at, so this is your traverse speed, so at what speed the tool is moving over the surface, so that is your speed rate. Okay, rotational speed is the RPM, at what rotation it is the tool is rotating, and traverse speed or speed rate is the speed at which it is moving on the surface. And the third parameter is your zinc foil thickness. Okay, so already as we have discussed, between the aluminum and copper, okay, we have a very thin foil of zinc which will be around 0.1 mm in thickness or 0.2 mm. Okay, so this was just explanation for you to understand what are our parameters. Once you understand the parameters, okay, then we'll see how to do the experimentation. Okay, So we'll go for the central composite design now. Okay, I'll stop this. Okay, sorry. Okay. Okay, I have to share the window. Okay. Okay, I can keep it small. Okay, so numerical value here. Okay, so we have discussed three parameters. Okay, independent parameters. So यहाँ पर numerical value I have increased to 3. Okay, enter factor ranges in terms of plus or minus 1. Okay, so I just name the parameter. So first parameter I will name it as rotational speed. Okay, you can keep it as it is. It's not required that you name it. You can name it later also, but I have time, so I will just enter it so that we understand exactly what is the parameter. Okay. Zinc foil thickness. Okay, so it was required for the welding compatibility. Again, units, you can write RPM here. Then here you can write the unit as mm per minute. Again, this is as per your experimentation. Okay, so you can change it if you want. So the low RPM used was 1000 RPM plus 1000 here in low, and in the highest we use 1400 RPM. Okay, next for the feed rate we use minimum feed rate of 5 mm per minute, and maximum we use as 15 mm per minute. Zinc foil thickness we used 0 is means without zinc foil, because we should know if we don't use a zinc foil, what is the condition of weld, whether it is a good weld or bad weld, and how, if it is bad weld, then how weak that weld is. Okay, so to know that we will do some experiments where the zinc foil thickness will be 0, that means absence of zinc foil, and then we'll use 0.4 as the highest. So in between we will use 0.12. So you will get the alpha values of alpha. Okay, so non-center points are 14, center points are 6. That means we will have to repeat the central experiment. So, yeah, experiments with center values. Okay, so center values are here 1200, then here it is 10 mm per minute, and here it is 0.2. So we have to do 6 experiments of the center value and other 14 experiments of non-center value. Alpha is given to us. Okay, so that is 1.68.
So I can change if I want.
If I go for changing blocks, okay, so I can change here, okay, the number of center points and all, but I am not changing this. And this is very important, the number of runs. Okay, so we are having 20 runs. Okay, so 20 experiments is all we are having. Okay, so we will press next here. Okay, so this is okay. I will press next. It will ask me the output. Output is your response. What is your response? So I have already entered here ultimate tensile strength. Unit is MPa. Okay, and I will finish. Okay, so based on here, I am created the design for me. Okay, so you can see 1 to 20 runs. Okay, already we have discussed that the number of runs were only, our experiments were only 20. Okay, so this way, at this point, I am able to generate my experimentation. Okay, now I will do the experiments. Okay, so after this DOE is established, based on this, like 1400 RPM, 5 mm per minute feed rate, and 0 mm thick coil, absence of thick coil, I will do this experiment. Okay, so based on this, we were doing this experiment on a CNC vertical milling machine. Okay, where we are able to attach our part in a fixture, and then we have this specially created friction stir welding, that is a solid state welding tool which we had clamped in our spindle. Okay, so based on that we did this solid state welding experiments, and we got all the values of the 20 experiments. So for sure, to do the manufacturing then you will have to cut the sample for your tensile test, or if you want to test for thermal conductivity, you will have to have a separate sample. If you want to test for hardness, you will require to make a separate sample. So of course, if you are doing a experiment on a larger workpiece, you can cut out three samples which you can use for your hardness, thermal conductivity, and tensile strength. Okay, so that way we can do if we are using a doing experimentation on a larger sample. So we had done the same, so we are able to get two uh, tensile test sample, two samples, one which we use for the tensile test, and another sample we use for our thermal conductivity test. Okay. So of course, for the thermal conductivity, we had to use a different setup, okay, for doing this testing part of thermal conductivity, okay, as per the ASME standard. Okay, so I will just rename them. Okay, so I will save this as unnamed. Okay, so already I have entered these values. So I will save time by directly opening the new file where I am already entered these values. Okay, so I will just show you how we have done the experiments. Okay, so this is the Excel sheet where I had we had done these experiments. Okay, and we had got these values for our 20 experiments. Okay, based on the experiments given by our design expert software. Okay, so once that was done, I entered all those values here in my Central Composite Design software. So I will directly open that file, which was a new file. Okay, fine. Okay, so everyone is able to see as per the number of runs, 1 run to 20 runs. I have already entered all the values which we have got from the implementation, and now this is complete. Okay, I have the input 3 parameters, output 1 parameter. Okay, of course we have the second output also, which was your thermal conductivity, but that we have analyzed separately. I have not done multi-object to multi-object optimization here. I have done single object optimizations for ultimate tensile strength, and similarly a single object optimization I have done separately for the thermal conductivity. Okay. So once you are established with the design, what we can do, we will see the summary. So this is your build information. RSM we have used runs 20 quadratic models. Okay, so I am also able to get the response. What was my minimum response I got for my tensile strength? What was the maximum response I got? And what is my mean standard deviation? All summarized data I am getting. Next we'll go for the evaluation. So evaluation you can see here. Okay, we have the intercept first. Then A value, A is nothing but your rotational speed. Okay. Then B your feed rate.
Zinc fault thickness, and then AB. AB is nothing but rotational speed and speed rate considered together. Okay. So that is product AB. Similarly, we are having AC, EC, and A square. A square is nothing but rotational speed square. If I think that maybe ABC can affect or have impact on my final values or final output, then I can click here, double click. So now M is model. So ABC is now considered as a model. Okay, but I will not do it by myself. First check what type of model I am having, then only I will select. Okay, you can select whatever you want. Okay, and you can eliminate it later on. Okay, so I am selecting this model. Okay, so let's yes. Okay, the model type is polynomial. Okay, okay. Next we'll go for analysis. So what analysis we can do? Before going to the analysis, we just see the results. Okay, so model terms are here. ABC, your BIF is given, standard error is given, your degree of freedom is given, that is 5 out of 6, and the recommendation is at least 3 lack of fit, and 4 pure freedom, which is there. So we are having 5 and 5, so this is okay. And so BIF is important. Okay, so BIF ideal value is 1. Okay, so that indicates the multipolarity. Okay, so multipolarity means we have A impacting B, B impacting C, so that doesn't happen. Okay, A is not impacting B, B is not impacting C. Yes, A is impacting output, B is impacting output. A and B are impacting output, that is okay, but A is not impacting B in any way. Okay, like your A is not impacting your feed rate. There is absolutely no relation, they are independent. Okay, so there is multipolarity that will also be understood. Okay, that is not multipolar. So go ahead. Then Pearson's sequences, matrix measurements you can check. Okay, next we go for the analysis. Okay, so in this analysis, your output is ultimate tensile strength. Linear regression, I am saying no transform. At this moment, I don't know what type of transform it is, but I should select no transform. Then fit summary is already this we have seen. So based on fit summary, your model or your software will tell you what type of model you should select. So linear, okay, so it is having a very high value of P, more than 0.05. Okay, then two factorial interaction, that is also high. Then quadratic, it is very less than 0.05, which is required. And then cubic, okay, it can be analyzed. So analyzed model, okay, this is also there. We can go for cubic also. Cubic also is good enough here. So analyzed model, we have few terms of cubic, like we may have ABC or we may have this PQ, but that is not better as compared to quadratic. Okay, so quadratic is suggested, so we will go for the quadratic model. Even here, sequential model sum of squares, that is also suggesting that your quadratic cases two factorial interaction, that is suggested for a quadratic model only. Then we see a model summary statistics, which is already showing your standard deviation, R square, adjusted R square, and Peltier. So all of them are suggesting that you go for your quadratic model. And finally, lack of fit test. So we have discussed that we get the p-value as 0.0074 less than 0.05, so we can go ahead. Now here we have to understand that the cubic is not good, okay, here in the lack of fit. Okay, so even if the cubic was good here in the fit summary, in the lack of fit test it fits. Okay, so you have to again see all the tests, not just the fit summary. You have to see the lack of fit test, you have to see the model summary statistics, you have to see the model, and then you have to decide what type of model you choose. So that is a quadratic model. Okay, so we are not selecting the model ourselves based on the data. The software is suggesting us the model, and based on that model we can use that model. Okay, so here but if you see which model we have selected here. Okay, so already I have selected quadratic only. If I am selecting ABC, then that model becomes cubic LS. Okay, and if I am selecting all cubic models, then it becomes a proper cubic model, which is not suggested by your software. So I will have to take A cube also, B cube also, C cube also. Okay, so up to this power 3, I will have to include all the terms. Okay. So I will avoid that. I know my model is quadratic. So you can just double click and you can remove this cubic term. Okay, it is the cubic. So this is the model. Okay, next we go for the N1. So this is the main diagram. Okay, so N1, so what is this here from the N1? So this is the main fact which tells you what independent parameter significant. Okay? So first you have to check whether your model is significant. So if your model is not significant, there is no point in doing the experimentation. Okay, because using a cubic model, where actually your model is quadratic, all your values may be wrong. Okay, so model should also be significant here. After the model, you will check the individual independent parameters. Okay, so parameter A, that is full RPM, that is having a very low value of P, that is the significant parameter. The human speed rate, you can see here, is significant. Mean fault is significant. Okay, and this is 0.04 less than 0.05, so this is also significant. AC is not significant. It's very close to 0.05, but it's still above it. Okay, so we see say that maybe not take AC. So AC is not significant based on our significance levels. AC is significant, and of course A square B square are also. That of it also, that is also. Okay, now we can see here the value is showing that A, G, C, AB, BC, A square, B square, C square are a significant term. Even lack of it suggests that this values are correct, this model is a good fit. Okay. So this we can say in terms of significant parameters. Okay. So AC here, which is the interaction between your tool RPM and your zinc foil thickness, that is not significant. That you can consider from this experiment. Next, we can see the diagnostics. Okay, so diagnostics we will plot the predicted versus actual. Okay, so what is your prediction and what is actual? So you can see there is very small difference between the prediction and actual. Then we just see residual versus factor. Okay, then residual versus run. So those are all you can see, and you can see the normal plot also. Okay, so normal plot you can see that most of your values are very close to your model and some values are outliers. Of course, that is going to happen when you are doing experimentations. We not have all points on the model line. We have some points somewhere in the experimentation. Okay, fine. So diagnostic is done. So you can check all these values. Leverage you can check. Okay, you can check the final report also. If I want this report the Excel form, I can download this report. Or if I want the individual plots, I can create this plot. Okay, normal plot, then residual versus predicted, or predicted versus actual. Okay, so you can see that the predicted values are very close to your actual values. Okay. Next, model graph that you see. Okay, so what is a model graph? Okay, so that shows me the value of ultimate tensile strength, that is your output, with respect to your parameter, that is parameter A, parameter B, which is shown on the X and Y axis, and based on this we can get this process window. So this is a process window, and this tells you, or this window or this plot tells you that if I am using a particular value of rotational speed, say if I am using 1300, so 1300 it is best that I use the RPM somewhere around 10, so that at least I will get your ultimate tensile strength more than 110. So you can see this quantity structure. So inside the quantity structure we have a ultimate tensile strength value of 120. So now you can see 120. Then this circle, anything within the circle has a minimum ultimate strength as 110. Okay, so if I am selecting 1300, then you should not select something like 30, because then we have ultimate tensile strength lesser than 100. Okay, so by some reason if you have to study 1300 and you want an optimum value, then you can go for this. Okay, 10 mm, so that you get your ultimate tensile strength closer to 115. Okay, somewhere between 110 to 115. Okay, next I will just see this AC. So this is your interactions you get AC and DC, how they are plotted. Next, if I want to check predicted versus actual, so this also we have already checked. Then you can check here. Okay, then if you want to check interactions, okay, so that interaction will check. So interaction AB, okay, so you can see as your A is changing, your B is also changing, okay, and they are having some relationship with each other, so interactive effect. Now this interactive effect will be telling your final output, okay. So AC also you can see there is some interaction between A and C, and similarly DC also there is some interactive effect between B and C. So as your A is increasing, your B is also increasing, and they are reducing simultaneously. Okay. So there is some amount of interaction here. This one will not see the interaction because it is a single parameter. Okay, and then you can see the 3D surface. Okay, so this is the 3D surface you can see. So So earlier what I had shown you was the plots, normal plots. Okay. So now I am in the 3D surface. Okay. So you have two options. Either you can see the counter or you can see the 3D surface. So 3D surface will show this tail, that is rotational spring, speed, feed rate, and based on a value of Z coil. So you have the Z coil is, I have kept it at the center, so the Z coil is 0.2. I can reduce it to 0. So your graph will change. I can increase it to 0.4. Again your graph is changing, and I will keep it as 0.2. Okay, so I keep 1. Okay, so for given value of Z coil thickness, you can check what is the ultimate tensile strength value you are getting. So it is very clear. If I am making it 0, you can see the values are reducing. Okay, my ultimate values are reducing. It's going lesser than 100. Similarly, if I am going for 0.4, it is reducing even further. It is reducing to below 80. Okay, but for the absolute value, which is 0.2, I am getting this highest amount of ultimate tensile. That is your output. Okay, so just you vary this and check. Okay, but I mean that will be a trial and error method. You don't need to do that. This is just for understanding how your output is varying with respect to change in the input parameter. Again, what you see downside here is the counter. Because this counter, if you want to see more clearly, you can go here and you can see the counter. Here also you can change your Z coil thickness, like it is here 0. So you can see if you are 0, the maximum you get is 100. Okay, you don't get more than 100. Okay, and here you don't get more than 90 if we are having the particular quantity. And for 0.2, we are getting output value is more than 120. Okay, so slightly more than 120. Okay, finally, if you want to see the cube, okay, the central composite design cube, okay, you can see here. So this 6 is suggesting that we are doing 6 number of experiments with the parameters of the central value. So the central value means your RPM as 1200 RPM, then your speed rate as 15 mm, sorry, 10 mm. Okay, minimum we are having 5 mm per minute, maximum we are had at 15 mm per minute. So we'll take the central value. Speed rate is 10 mm per minute, and we will take the central value of the Z coil. So minimum Z coil thickness is 0 mm, maximum is 0.4 mm. So we will take the central value 0.4 mm. So with these central parameters, we will do 6 experiments, and the remaining we will be doing 1 experiment each as suggested by your model. Okay, so where you have seen this model, okay, in the design. Okay, so this was already suggested. I did not create this. Okay, as soon as I entered the values, the software created this DOE design of experiment for us, and based on this, I have done the experiment. Okay, so you can do this numerical and graphical optimization so that you can see that. So when we are doing the graphical, we have to give in the numerical what is your range. Okay, so full RPM I will keep it in range. Then speed rate again I will keep it in range. Z coil again then. Ultimate tensile strength. My objective is to maximize the strength. If it is something else, okay, we can minimize it. Like if it is a resistivity, then I will try to minimize it. So lesser resistivity, electrical resistivity, higher electrical conductivity. So if resistivity is the case, I will try to minimize. If your ultimate tensile strength is the case, I will try to maximize. So I will select maximize here, and I get this output. Here you can give the importance levels. What is the importance level of each factor? Okay. Okay, so that you can give, and you get optimization here. Okay. So I can see it in the graph. Okay. Based on your value, you are getting this prediction, and you are getting the desirability. Okay, so what should be my parameters? So maximum desirability is 1, minimum desirability will be less than 0.5, 0.6. Then you get. Okay. So our target is to go for maximum desirability where I get a optimum value. Okay, so next we go for the prediction. So already I have given this range, and based on this I am getting the prediction mean, let's say 122.47 as a predicted mean I'm getting. Okay, so this is the prediction I'm getting based on the experimentation. So this prediction is for your maximum value. Okay, and what value it is suggesting me that we should use 1193 as the RPM. Then speed rate I should use 9.89, and the zinc oil thickness I should use at 0.17. Okay, if I'm using these parameters, that is the optimum, and I can get the value of 123.47. Of course, we are getting this at 1210 and 0.2. Okay, so 0.2 is very close to 0.17 because in the market you should also be able to get this. Okay, it will suggest 0.17, but if you in the market you will get this in poison 0.1 mm, 0.2 mm, 0.4 mm. Okay, so you won't get 0.17. Okay, so that will be a technical limitation which will be there. So what you just suggested, we cannot exactly use it, but we can use a very close value. So I was able to get 0.2 mm twice, so I used that. Speed rate, of course, if you are on a CNC machine, you can select this exactly 1193, 9.89. But anyway, we selected 1210, which was also doing very good value. Okay, so this is the prediction. Okay, so prediction gives us that at what value we are getting the maximum output. Okay, so if you can do that experiment, it's fine. If you cannot do that experiment, you use parameters which are very close to the predicted predicted parameters. Okay, you can use those values, and then you can use the analysis summary. So we have this intercept, we have various points. Okay, and based on this coefficient table. Okay, so what is the coefficient? If we have any mathematical model, so we should find the coefficient of those models. Okay, those parameters. Okay, so here we are having this parameters, the coefficient values, and the intercept. Okay, so y equals to mx plus 3. Okay, or it may be a linear equation, it may be quadratic equation. So this is the intercept what we get, and this is your ultimate intercept, and these are your values. Okay, actual equation you can get it from here. Actual equation. So the ultimate intercept is nothing but minus 798 plus 1.33 into A plus 25.8 into B plus 74.1 into C plus minus 0014 into AB and so on. Okay. Again, there are some parameters which are not significant that you can eliminate. You may not use those in your final model. We can use only the model, parameters which are significant. Okay, so here you can see the model comparison and your coded. Okay, so you can have the coded equation also, which will be the EDC term. If you want the equation the actual terms, you can have it. So this way you can do the analysis. Okay. Coefficient tables also we have. Okay, so we have done the prediction. Okay, we have predicted the parameters for which we can get the maximum values. Okay, again you can change here. Okay, what are your parameters? If you want to change the limits, okay, or anything, if you want to change the upper and lower limits, okay, that you can do. You can plot. AC. Okay, and DC. So you see the how your ultimate intercept is varying with to each parameter. I think if you want to see all the parameters, then you have to go for this numerical optimization or 3D. Okay, you can go to the graphical. Okay, numerical is not showing if I am having this. Graphical. Very modern. Okay, there is some issue. So we are not able to generate the model. Okay, but we already seen these models and we have seen this graph. Now we are able to generate this graph for the counter and for the 3D surface. Again, if you want to see the various elements of your desirability or the ultimate tensile strength based on your center points, axial points. So that also you can see here. So you can see the prediction value, it is more close to your central values where you are having central values of your B point, RPM and speed rate. And at the end also you will understand what is your tensile strength. So 62 is your tensile strength or desirability 0.3. Okay, so even from the desirability block, okay, cube, you can get to know that Z is the optimum value. Okay, so desirability should be more than 0.6, 0.7. Okay, ideally it should be 1. Okay, if you want to get the maximum value for this ultimate. Okay, I have selected all responses. Okay, that's why. Okay, so if I'm selecting all responses, you get this. Okay, if I'm selecting ultimate tensile strength, it will only give me the ultimate tensile strength, and now it will show me my graph. Okay, because I have selected all responses, it was not showing me the graph. Okay, so I just select for desirability. If you want to check what is the desirability, and if you want to check the actual output, that is your EPS. Okay, so that also you can check in the video. Okay, so these models will be helpful to use in your presentation, if you are doing your thesis work or if you are doing any such project. So this will be helpful because these models show you what is your reflection and how your final output is changing with respect to your independent variable. Okay, so this is all. If you have any questions, you can please feel free to ask. Okay, so you may even try Minitab. I have not tried because when I have tried last time, I did not get this quadratic modeling there. Maybe they may have included it by now. Okay, so Minitab is more readily available. So you can check that also if you are able to use this central complex time quadratic terms. Which should be the okay. So if you are still want to do a research, you can always use an official email ID, or you can use your colleague's email ID if you are working together on a project to do this analysis. You are having ready with your experimentation. Okay, you can complete this in maybe a day's work. Okay, so one day sufficient to do this analysis and further. Okay, so we have started with the design. Okay, we made this design. Same thing going for this analysis of the model. You have to check whether your model is correct. Okay, all your parameters, fixed summary, sequential model sum of squares, model summary, lack of width. So all your tests, all the 4 tests are suggesting that you go for the quadratic model. Okay, then only you can go for the quadratic model. Even if one test is failing. Say like in here you can go for cubic, but even if one test is failing in cubic, it's recommended not to go with the cubic model. You can go for the quadratic model. You can select the model terms. If I want, you can add in the okay. Remove them. I can go for the cubic model from here. Okay. If I want, okay. In ANOVA, I will give the significance of the parameters, which is very important for our study because in our study that is the main thing. We want to check how our parameters, independent parameters, and their interactive effect is affecting my final output. Then you can do this diagnostic for your checking of the predicted versus actual, checking your normal plot, then model graph you can see, the 3D surface you can see here, and next we can go for this model comparison. Then you can find this question. Okay, using the question coded or uncoded, you can get the actual equation. So this is the actual equation which you can directly use for your mathematical model. Okay, so your equation can be in terms of actual terms or it can be in terms of your coded factors. So thank you all. Any questions, please feel free to ask.
If anybody is having query, you can ask to sir, or you can post in a chat box. I think sir, nobody is having queries or questions.
Okay. Okay, good. Okay, so the software is not difficult. Only you have to see what are the various terms, what is GIS, what is calculate square values, so good center points. Once you understand the terms, it will be easy to do the document.
Hello. Feedback link is there in the chat box for this session only. I think sir, nobody is having questions. So shall we stop the session? Thank you sir for your valuable session and guidance.
Thank you very much.
Thank you sir. Thank you so much.
Thank you, Mr. Panaskar sir, for your insightful session.
Thank you very much, sir.
If possible, try to join the validity session at 2 p.m. so that you can once again have a chance to interact with participants.
Yes.
So, participant, this is all about the hands-on session taken up by Professor Panaskar sir. I hope you have a experience about the execution in optimization. So till that moment, take a lunch break and see you on 2 p.m. for validity function. Thank you all of you, and request to all of you to fill the feedback form, which is another mandatory requirement for your issuing of the certificate. Give the realistic feedback so that we can analyze it properly. Okay, chalo. Thank you, sir. Thank you, Panaskar sir, Thank you, Solanki sir, for your valuable inputs. See you soon. Thank you, sir. After 5 minutes, turn off the meeting, turn off the recording, and a participant be ensure your presence for the validity function. Thank you. I'm close after 5 minutes. Let them feel the feedback.
Yes, sir.